Hey everybody, Adam Savage here in my cave. I've got a surface plate in front of me. Um, this is an old surface plate that I got back in 2005 when I was helping set up, I think M7 in its second location. Um, I have beaten this up over the years, but I want to talk about these for a second because I want to talk about something someone gave me, and we're going to get into some metrology today. Metrology is the science of measuring things. Um, it is a deep and storied science, and it is an amazing. When you study and you look into the measurement of things, you very quickly confront the absolute limits of our knowledge and our ability to see. And it's really fascinating. Um, I was just in Seattle at the Emerald City Comic Con, and a fan brought this to my table. And it is a bit of metrology equipment that I didn't know about. I didn't know this existed. It's made by our great friends at Mitutoyo. Mitutoyo has given me a couple of sets of amazing gauge blocks. And, well, we're going to cover something else that they just sent me. But this is a device that I did not know they made, which, look, they think they make over 5,000 separate things. Just think about that for like a second. This company makes 5,000 separate things. I can't even wrap my head around. So I'm sorry. By the way, I wanted to state at the top line of this, not sponsored by Mitutoyo. They're just good friends of the channel, and I speak to them occasionally. And so I happen to know they make over 5,000 separate SKUs. A SKU is the acronym SKU, and it stands for Shelf Kit Unit, which is a very weird phrase, and yet in retail, it's all about the SKU. It's all about fulfillment, and it's all about the SKU. So now that you know what SKU means, Mitutoyo has over 5,000 of them. But look at this masterpiece. Yeah, I'm showing it to this camera here. This right here is a thickness gauge. It's for measuring the thickness of things. Oh, right. Let me show you what it measures. I've covered on the channel how much I like dial calipers with an actual dial. That I don't like digital calipers because they don't physicalize the measurement for me enough. But I want to tell you, when I bought my first set of digital calipers, I probably told this story on the channel, but it bears repeating. I bought my first set of digital calipers for $30 at Fox Hardware on 4th and Market. $30 was a lot of money for me back in 1991. But I had been doing enough like high-level precision work that I needed a real set of calipers. Now, these are Brown and Sharps. They cost more when they were new than the ones that I bought. But like, we'll include a link to a cheap mechanical metallic caliper. I think everyone should have one of these in the house. It's a fascinating look at the world. You take a piece of paper from a catalog. Well, actually, again, we're going to use the thickness gauge. I just brought this out as an example of your sort of, this measures thickness. It measures internal diameter, outer diameter. It measures the step. It has a lot of different functions. This is a single or very low number function item. But here we go. We're going to measure something here. We're going to see that this catalog page is 3. Come on. There we go. Oh, look at that. 3.5 thousandths thick. Ooh. But, oh, yeah, there we go. So we can actually see that. Okay, let's just talk about this for a second. Every single line on this is 1,000th of an inch. Every single little tick mark is 1,000th of an inch. So that is its resolution. And it says here 001 to 375. And so you can actually, if you move this like, half, you can move this like a tiny bit. You can actually see measurements smaller than 1,000th, but in terms of coming up to a direct measurement, it's a little spongier. But your gauge returning to zero is absolutely mission critical. And you can see that it lands to the right side of the zero mark here, which is something that if I was, that's just how I'm holding it, which is something that, like, if I'm measuring something highly precisely, I am going to want to know which side of the tick mark it falls on. Going around your house and even like, here, let's crack a book and measure a page here. Oh, here we go. Oh, wait. Oh, I'm sorry. There, I'm all zoomed in there. There we go. So if I take this page, and you can see these pages are much thicker. They're almost 7 thousandths thick. Here we go. We're going to pull out a hair. That's it. All right. Can you see that? Can you even see? Yeah, dude, can you even see hair, bro? Okay, there's a hair. Here we're going. There you go. My hair, which is very fine, is about 1.5 thousandths thick. Off the top of my head. There you go. Like, is that freaking cool? I've been carrying this around in my pocket since it was given to me because I just think this is such a beautiful object. Also, side note entirely. If you're watching Severance, if you are on the team that makes Severance, can I just pay you the highest compliment for the close-ups of the meters in Severance? The Lumen branded blood pressure cuff, the Lumen branded woe meter. All of those close-ups are chef's kiss perfect. Okay. So what is a surface plate? A surface plate is a super flat thing. Made to be super flat, made so that you can make measurements using this and know that it is incredibly flat. How flat is flat? I believe that one like this is probably flat to less than 1/2 thousandth of an inch across its diagonals, which means if you had a much bigger measuring machine and you could measure the flatness of this, you'd find that there was almost no variance in the height and no twisting whatsoever. This is granite. Granite? I think it's granite. Anyway, the surface block comes into play because I just received a brand new height gauge that I've been interested in adding to my collection from our friends at Michutoyo. And I'm going to crack it out and unpack it on camera for you right now. I'm just going to go back to 5,000 SKUs. That's 5,000. That's probably not 5,000 different boxes, different manuals, different batteries, but it's probably close. It's probably close to that. I don't even know what most of. Oh, okay. I know what that is. I know what that is. Oh. It's so pretty. kind of the main reason I broke out the surface plate is because a height gauge sitting on just a raw, half-painted 70-year-old table surface feels just wrong. Right. Oh, I see what's happening here. Oh, yes, we need a little cleanup there. Clean up on aisle 4. I actually really, really want to. I would like to get a rag on that before I start moving it around. Most likely they coated this with some protectant so that it wouldn't rust during shipping or tarnish in any way. That would be my guess. I'm seeing a little residue show up here from applying just a little bit of solvent. Yeah, I can see it. Excellent. We're going to make sure there's no marks on the bottom. This is absolutely the sort of minimum threshold of attention to detail if you're going to be measuring stuff at a very high level. All right. This is part of it. Part of it. This is part of it. Part of it. Yes. David S. Pumpkins. Oh, yes. Probe. Oh my gosh, that's awesome. I got to tell you, the feel, that feel, it's a nice feel. Very, very shallow rack on there. Amazing. Okay, so we're going to lower this down. Well, I'm going to pull that. Now, you might look at that and wonder why it has such a sharp edge and clearly hardened. The answer is the edge of that little knife is the business end of this whole deal. So yeah, this is the business end of this measurement device, and your ability to see it really close is really important to its functioning. There is a secondary marvelous thing. Okay, first off, I want to show you how I started out in the special effects industry using height gauges. Come on, let go. That's it. Yep. Excellent. Right, good. And that is a real knife edge. That's very, very sharp. Okay, first test case for a height gauge. First of all of the early height gauges I worked with were borrowed because even the cheapest version of this back when I was just beginning was well over $100. In fact, I remember specifically, I think, that Carol and Kim in the ILM shop figured out that there was some company that was selling a height gauge that if you ordered one for $100, they sent you like the $300 version. They both got height gauges out of that. By the time I ordered, because they gave me the address, they had already figured out their mistake. But height gauges, but height gauges were something that every shop I worked in had, and it was for stuff like this. Let's say you had yourself a baby Grogu puppet, and you wanted to drill a hole that went perfectly perfectly horizontally through some plane of the baby's torso. Well, I think you can imagine that utilizing calipers for figuring out where that hole goes is fraught and difficult, right? You're trying to get this rack correctly, and those measurements can change, and each foot is a different shape, so that could lead to a different measurement. But with a height gauge, all of a sudden, it becomes almost trivial. And in the effects shops we worked in, I'm going to do it like this so that I can fit them both on here. In the effects shop that I work in the effects shops that I worked in, this was a regular technique we would do, is like scribe a line. You can see it's a nice scribe. That's a helpful thing about this being sharp. And in fact, it's sharp for a markup reason. Hold on. You see me all the time using my calipers. Let's go to this. You see me all the time using my calipers to make marks like this, dragging them across and marking them through the blue marking fluid. And some people get upset about that, about using calipers to scribe lines. I am a film machinist, and that is just part of how we do what we do. But if you really wanted to go the correct route, and you'll see ClickSpring using this kind of measurement device all the time. Actually, let's do it over there so that both cameras can see. Let's do that. Let's do that. Let's come in here. Oh, look at that. That's great. So you can come in with presuming that your ends are all nice and flat, you come in with your height gauge and you make some really, really nice marks. Plus, it allows you to make marks equidistant from both sides. Yeah. That is always, always, always going to be a much more accurate mark than the one you can make with your calipers. I think it's going to be more accurate than the one you can make with a straight edge and a scribe. But Chris from ClickSpring regularly blows my freaking mind with his metrology and precision. There's another function of these, and I'm really trying to find a part in here to mess with. Okay, well, another one is this. Let us say you had a hemisphere like this, and you wanted to cut it to a really specific level. Let's say you wanted to cut it to a really specific level. Again, this is where this tool really, really wins. So, and then we'll lock it. And on this front, and there you have a line to cut to that you know is within a very, very high tolerance, exactly where you want that line to be. There's one more. Okay, I need this one piece. All right, in order to do this, in order to make this work, I'm going to have to pull out my vacuum form machine. But that's okay. Let's do it. Let's pull it out. Okay, so I'm going to put a piece of 040 styrene in here. I'm going to turn on the heat. All right, heat's starting up. This is, I'm not even sure what this is. This could be a piece of an Iron Man costume. We're going to vacuum form it. And then I'm going to show you how useful the height gauge can be. I was just reminiscing in my head about how much fun it was to have one of these at your desk when you were model making. I didn't work on many jobs in which I did because, like I said, my mentor, Mitch Romanowski, had one of these. I did not. But I executed many jobs with him in which this sat on our workbench and was just like the most amazing bit of kit. All right, it's starting to droop. In general, you want this to droop somewhere close to the depth that it wants to pull at. We'll see. All right, let's give it a shot. Yeah, this will actually be great. All right, there is our vacuum form. Hello there. And this is a common thing with a vacuum form. This is, I didn't pull a perfect form, and that was on purpose. I wanted a little bit of webbing down here. You can see this is what happens to a vacuum form. If you haven't let the plastic warm up enough. And also you can decrease the amount of webbing down here by putting a helper down. And a helper would be like a ring just slightly bigger than that. All packaging, all vacuum form packaging uses a secondary helper to help shape the plastic and stretch it correctly before it goes on the form. So in special effects, you're frequently working with imperfect vacuum forms to try and get set pieces out. Come on. This isn't letting go. It doesn't, it should let go. Hold on. It's okay. Sometimes this happens with vacuum forms. I haven't had it happen this bad in a long time. I didn't feel like my model was sticky. Come on. I'll just try that. I'll be using a thinner plastic. Put this down. Sorry, this is taking so much longer than I expected it to. This is some vacuum form spaceship greebling I demonstrated how to do a few months ago. We'll include a link to this build on the channel. This is a really fun, just using a notcher and freehanding some spaceship details. Interestingly, when you first heat vacuum form, I know I'm bouncing back and forth like a tennis match. When you first heat a vacuum form, the first thing that the plastic does is bow up, and that's because you're heating the top surface and it's expanding it, so the whole thing bows up. And then it settles out as the heat goes through the whole width of the plastic, and only then does it start to drop. But in the beginning, you have the part that's expanding is fatter and warmer than the part underneath it, and until it's all the same thickness, same heat, it's going to bow and then settle. Now it's starting to settle down. Settle down. I know I should put some cornstarch on here. I hope springs eternal that this won't mess me up. Okay. Perfect tool, that vacuum former. All right. That's how it's supposed to come out. And it kept some of my plastic in here, which is fine. I can glue that back on. Okay, but let's say, actually it all came off. Great. We're going to there. So we have our form here, and we want to cut it out really, really square. Now you can do that with an X-Acto lathe, but it's not going to be as amazing as you want it to be. My method is to score around. Actually, I'm making sure you're seeing all this. That's great. Here we go. Is to score all the way around. I normally use an X-Acto, not a Leatherman for this, but the Leatherman's what I got. And we'll score and break and separate. Okay, so now what I have is a vacuum form in which I know that this bottom edge is flat and square to the model that I'm interested in adjusting the height of. Then I bring in my height gauge. Let's get you a really nice sort of view of this. Yeah, 2. Yes, great. Just in case. You bring in, actually, I'm going to bring it in even lower. Okay. Now, okay. So here is what you're going to get to witness here is you choose this height and then you drag it around. Now, I'm actually cutting into the styrene here with the knife edge of my height gauge. It's actually dimensionally making a mark in there, and I can keep on going around and deepen that mark. It's making little ribbons of plastic, so I know that I'm removing material. And there's a reason behind this. I'm not just over marking this. I'm actually scoring it. And I will tell you that you might end up working with some very strange shapes that you need to find a specific parallel to the bottom on. That's where this thing really shows its metal. So what do I do now that I've scored this? Well, I do what I can always do with styrene when I've scored it is I can break it on the score. There we go. And I can just go around and now I know it's not absolutely perfect, but I know that that is a very flat bottom. I would probably do one last pass on this on a piece of sandpaper like that. Sorry for the fingers on chalkboard feeling. That would be how I'd finish this. But dude, the height gauge is one of the best tools for model making when you're doing vacuum forming and spaceships. I know it's a really weird one. So what is a height gauge normally used for, you ask? Well, let us demonstrate some of that, shall we? So let's bring this up. I just love the operation on this, dude. We'll pull out. Now, so this is a blade specifically for doing layout like this on an object. That's why the ends are hardened. It's why the end of this is so freaking sharp and beautiful. Yeah. So we will put that over here and we'll bring in our, we'll bring in our indicator holder. So you can, this is an indicator. You can also have an indicator out here. And here's how you would go and utilize such a thing. And Mitutoyo has sent me an absolutely gorgeous indicator. And this is to 4 zeros and a 1. Am I right about that? No, 3 zeros and a 1. So that is 1/10,000th of an inch that this will register. 1/10,000th of an inch, or 2.5 microns for those keeping score at home. So let us try utilizing this for what it is purpose it's for. Hang on just a sec. I'm gonna get another couple of things. All right. This right here is the 1, 2, 3 block I have had for 15 years. I use it for everything. It is a filthy. It is this look. It is still very useful to me. I can use it as a stand, as a model making tool. But if I wanted to use it to precisely measure 1, 2, or 3 inches, I would be hoisted on my own petard. Let's take a look at how. So this is exactly one of the ways in which you would use a height gauge, is to test the flatness of something that you are making. So you'd adjust the height gauge so it came down. And okay, so I'm going to adjust this to 0. There we go. We're going to lock it. Nope. So we're currently at 0 on this gauge. And if I move it, you'll see it. There we go. Down, up. You see that? It's below. It's above. It's like literally I'm measuring, in some cases, the dirt or burrs. You can see this moving. It's moving down. It's moving up. This is definitely showing me a small variance. Okay. I think my saying I would be hoisted on my petard was a bit of a over exaggeration, but what you can see when you use this gauge on this 1, 2, 3 block that's very old is it goes up and down. So let us pull out a control surface, shall we? These are some brand new high-end gauge blocks that I just bought, and literally they're part of my kit to only be for use in metrology or machine setups where their accuracy is important. So I'm about to open these for the very first time. And we will do a little bit of cleaning some of the oil that was on them in shipping. Right off the bat, there's actually a significant measurement difference. This is 3/10 thicker. Let's double check that. Yeah. Yeah. I don't think this is anywhere close to an inch anywhere close to an inch. 3/10,000ths under an inch. But it's measurable. That's what this device is for. And so then as we move this device, oh, right, let me get this zeroed out. Okay, I think I'm running into trouble. Okay, I think I'm running into trouble measuring this on it. Hold on just a second. This is a new surface plate that I also just received from a tutorial. I was thinking I could do this demo with the old one, but I no longer think that that's feasible. So we're going to do it with this one. Let's see here. And that is a flat object. That is a very nice. A very nicely flat object right there. And this is one of the ways that quality control in a factory would be maintaining a knowledge of how accurate the parts coming out of the factory were with a setup not dissimilar to this. I have been wanting to buy some older. Do I need to have this in front of me right now? Maybe not. All of that work to get that one shot, but it was worth it. This is such a cool thing. I have been wanting to do more tool restoration of some old tools. I just picked up this 1,200-pound pantograph mill, and there's some real metrology necessary to make some old machines sing. And one of them is to do some scraping. So you make the flat parts incredibly flat, and you work hard using metrology to make sure your parts are super parallel to each other and parallel to the lines that you need them parallel to. And it all begins with having a reference surface like this. This is grade B. Grade B is a basic shop grade. Grade 0 is exponentially more precise and more expensive. And they make these by lapping them. And I think they make the super expensive ones by lapping them for longer so that they're even flatter. But this here, grade B, 18-inch square surface plate, plenty for me. It gets stored underneath a wooden cover. I put one of these towels on top of it. Oh, also, it sits on it has 3 feet, and it is calibrated to sit on those feet. That's really important. Here's how flat it is. In the manual for this, in the calibration documents that come with it, they explain that if you put it on other feet than the one that is glued to its bottom, they will not guarantee flatness across the entire thing, because that can actually shift how it's moving. And I know it seems crazy for something as heavy and literally monolithic, single stone, as a chunk of granite here can actually get warped by not sitting on the calibrated feet. It can. And it does. It is, again, not a measurement that would concern me whatsoever. But here's what I'd love to suggest that you do if you're at all fascinated by these videos is go to the online link that we'll include in the description, where we have a few different $22 calipers that you can purchase right now. $22. That is a nice low threshold to entry. And they will be plenty accurate enough for you. And they are plenty accurate enough for me. All of this is like, it's deeply my hobby level fascination with this stuff. And my ongoing desire to chase zeros. But there is so much fun to be had taking around a pair of calipers like this, or a thickness gauge like this, and do like I did in the beginning of this video. Measure one of your hairs. Measure one of your eyelashes. They will be different. Measure several pieces of paper. The thinnest paper that is probably in your house is a rolling paper. Those are almost exactly 1/1000th of an inch thick. And in fact, there's a classic machinist technique of it's called touching off, using a piece of paper. You're bringing a milling bit over to something you want to cut, and you want to make sure that you know exactly what the touch point is, exactly where the milling bit starts to cut. Well, one way to do that is to hold a piece of rolling paper between the milling bit as it's spinning and the stuff you want to cut, and you slowly move the bit closer, and when it grabs the paper but does not mark the thing, that's how slowly you've got to turn it, you know that you are 1/1000th of an inch away, 25 microns, give or take. Measuring things really carefully is a wonderful lens with which to view the world and to increase the granularity of our understanding of it. You can feel the difference between a micron, a couple microns on a surface. You can easily feel 1/1000th of an inch. You might not imagine that, but Scotch tape is what, 3 thou? Anyway, get yourself a caliper, go measure everything that you can. I've got one more gauge I wanted to show you. And by the way, thanks to Mitutoyo for sending this incredible, beautiful piece of kit. It will, yeah, I'm going to make a box for it. Clearly, I got to make a box for it. Yeah, that'll be one of the very next builds. But I wanted to show you a couple of other gauges that showed up on Craigslist recently. And they are called force gauges. So this is one, and this is another one. And they are made by, the glass fell out. They are made by Dillon and Company, W.C. Dillon, out of Van Nuys, California. Probably will pop right back in. It did. Okay. So a force gauge, it has a flat bottom. There's actually a threaded hole in there so that you can attach it to something. This has also a threaded hole. And then it's got this divot up at the top, and that's where you put the force in force gauge. And it'll be easier to see on this. When you put force on it, the dial moves. So this is simply translating how much this steel bends, this heavy, heavy chunk of steel, nonetheless bends enough for me to see, for me to show that the dial moves. And when it goes all the way up to the top here, is that 450 pounds, 500 pound capacity, it's lifting 500 pounds. Yep. How about that? This one goes up to 2,500 pounds. And again, it's just a big chunk of steel that has been carefully cut with calibration. Carefully cut with calibration. A little alliteration from anxious anchorman placed in powerful posts. If you haven't seen Broadcast News, you should see it. It's a wonderful movie. One of the things I love about these two force gauges is they're adjustable. And every good piece of metrology should be adjustable so that you can alter its precision over time when it wears out or when it changes. And in this case, the way in which you calibrate it is this hexagonal nut. It moves from side to side, allowing a very highly precise level of calibration. I think this is a beautifully ingenious idea. As this moves, it changes the angle, and it gives you, with your big dumb fingers, the sensitivity required to zero out the needle. These were like $20 a piece on Craigslist, and I just had to get them. We used force gauges on Mythbusters all the time. This can help you know how much force you're putting on something to set it. This can help you understand things about your spindle, or these are actually scales. I can put weight on, I can hang a weight off of this from here and know how much it weighs based on this. So these are also really, really small but precise scales. And these are also actually some lovely indicators that were custom made for Dylan, I guess, because they're branded. And again, like I said, I just think this equipment is beautiful. Its functionality is beautiful to me, but its aesthetics specifically are also beautiful to me. And when I see them for a really good deal, reader, I pick them up. So there we go. We'll put this guy back in there. And we'll put this guy back in its home. And oh, there's a ball bearing there. That's also for giving you a point source. I'm missing the ball bearing in this one. Measuring equipment is beautiful. Yep, full stop. I love me some measuring equipment of any kind. In the comments, please let me know if you know of something that's like as beautiful as this that we should know about. Also, last thing I want to show you on the back of this are the decimal equivalents of 64ths, 32nds, and 16ths. This is actually really, really useful. And it's reasonable to like read this a few dozen times until you start to remember some of these. It's great to have some key measurements in your head. What key measurements are in my head, you ask? Well, I know that a 16th of an inch is 0.0625, and a 32nd of an inch is 0.3125. Those two are really easy because the 32nd of an inch has a 3 in its actual number, 0.3125, 0.03125. I know that the tap drill for a quarter 20 is a number 7. I know that the tap drill for 440 is a number 43. key things like that. Hold them in your head. They come in handy from time to time. Thank you guys for joining me on this deep dive into my metrological fascinations. I'll see you next time. And thanks to Mitutoyo for this beautiful equipment. They are good friends of the channel. And while this is not sponsored by them, it is inspired by them. So I'll see you guys next time. Cheers.